Welcome to this Unreal Engine tutorial. Today we will be talking about debugging. It's a very general concept, so of course this will work both in Unreal Engine 4 and Unreal Engine 5. Let's jump into it. So here we are inside of Unreal Engine 4. This is version 4.26 if you want to follow along today. But let's start off with talking about what is debugging. So debugging is generally the concept of troubleshooting your software. If you have run into some kind of a problem and you want to figure out what is causing the problem so you can fix it, debugging is what you will be applying to fix this. Now, the way you can debug in Unreal Engine is there are a multitude of ways, and we will be going through some of the more widely used and most commonly used and easily used ways for you to try and narrow down when you have a problem to what is the source of the issue, and then how you can proceed going forward to try and limit the amount of problem areas that you have until you find whatever is the problem. So if you have been following along in my tutorials earlier, you have seen that when we run into an issue, most of the time what we will use is the print string. And the print string is a very flexible and useful node to use for troubleshooting and debugging. It should not be frowned upon. I know that some people do not like it, but it definitely has its uses. And the print string, in addition to the other things we will be going through, have their place where they are the most efficient tool to use. But we will be going through a variety of different tools so that you have something available to you to use regardless of the situation that you will be in. Anyway, so now we are inside of the third person character, and we're gonna be doing some demonstrations about different problems. So if we have here in our event for the E key, for example. So the most commonly used is, like I said, the print string, which is basically just a print string node, and then you type in some kind of information like E key pressed, so that when you play the game and then when you try to do something, you can see that, okay, well, I'm reaching this code and this particular thing is happening. So it's a very good tool to use to see that a specific thing is happening for you in code. And the places where print strings might be better than the other options we will be talking about later is, for example, when you want to have something happen over a period of time instead of analyzing a specific frame. This will hopefully become more clear later on when we've talked about all the different tools that we will be going through. But just keep that in mind, that this is generally something that's used for less time insensitive situations, but it can be used for a single frame as well, of course. So let's leave this for now, and let's talk about the next way you can debug something. So let's implement some kind of logic here. Let's make a variable, and we'll call this a execute code. And this is going to be a boolean. And we're going to drag this out here, and we're going to have a branch, an if statement, and we're going to connect them like so. And then we're going to say if this is true, we're going to print a string, for example. Now, if I were to press E now, nothing would happen, and print string would show us that, okay, we're not reaching this point. So if you were in this situation and you expected it to reach this point, then now you have narrowed it down that this true statement is not happening. So what could be happening is, for example, that the false happens here instead, which we don't currently have any code to, or it could be that this specific event would not be firing, for example. In this particular case, we know that this is firing, but this is a good opportunity for us to go and use debugging for breakpoints. So breakpoints are if you're not aware, in programming you set out these stops in the code, which tells the code that when runtime is happening, so when the program is running, if it reaches this point in the code, you want the execution to stop so that you can manually take over and then step the code forwards in the speed and then analyze the data as you have it in that particular frame in time. So to do this for this example, what we do is we right click on this event for this example, and then we go to add breakpoint. And you can see that this red circle appears. This shows that we have a breakpoint over here and that it's active. You can also go here and you can disable and remove breakpoint. Disabling of a breakpoint will mean that it's hollow like this, and means that it will execute just like there was no breakpoint, but there has been set a breakpoint here before if you wanted to enable it again like this. Or you can just remove the breakpoint and then it will be removed completely and we will be back where we started. So let's add our breakpoint again, and we compile and save and we run, and then we press our key. So this is what you generally end up having. It could be that you end up in this, you see everything here is grayed out and such. It means that the code has now frozen in time. Nothing is being executed right now. And it is just waiting for you to continue with the code. And that is why we're here. And you can see that we're in a simulating mode right now, and it's showing us with this big arrow where we are currently in the code. And from here we have some options how to operate in the code. So the most commonly used keys that you will be using are these: the step into, the step over, and the step out. To describe these briefly, if you want to use the step into, this one would do nothing for this particular matter here where we have this event, because step into is used for, if we imagine that this was not an if statement, but this was instead a function or a macro or something like that, that we had like encapsulated a bunch of code inside of, and it's represented by a node. Step into would allow us, if we're standing here with the arrow and click step into, or pressing the F11 key, which is the default key for this function, it would allow us to step into that function or that macro and end up debugging inside of that instead. And then if we were inside of that macro or that function, we could use the step out key to abort everything we're doing inside that function and just go to the level above, which would be this level then in this case. The step over is the normal used key, because it's most of the time you just skip from node to node unless you have a very specific place you want to be, because if we had a problem in the function here, we thought, then we would probably be putting our breakpoint in there rather than here. But since it's now coming down to trying to determine where is the issue, then you might be starting very broadly and starting like at the first point where you know the issue should be arising, and then working your way from there, of course. Anyway, I hope that made sense and that you followed along, but so now that we are here, we can use this step over that I spoke of, and that means that we now jump to this branch over here, and we can see this execution node showing us that this is the step that we took to get here. While we are in debug mode like this with breakpoints, we can examine variables. So for example here we have this execute code, which is a boolean that's being sent in here to be analyzed to see which path that we will be taking. If we just hover over that with the mouse, you can see what our current value is. And since we never set a default value for this boolean, it's going to be false by default. Which means that in this if branch, it will be trying to go down here, and that's why we're not ending up over here. You also have some other options. You can right click and you can say something like find references. And you can also, if you, now I right clicked on the edge here, but if you right click on the middle, where the connecting pin is, you can see that we have something called watch this value, which is something that allows you to have this value being displayed without having to hover over it with your mouse key, for example. So if you wanted an easy display of the values. So now what would happen if we were to continue here? Well, if we press step over now, it will go into the false node, which doesn't have any code, which means that it would proceed with the game like normal. So, like so. Now you see that it looks like it's simulating, but we don't see any execution branches here like we did before. But if we go back to the game now, you can see that it's actually moving again and everything is operating like normal. And this would happen until we press the key again and end up in the debug screen again. So that's how breakpoints work generally. So breakpoints' strengths are when you have a very specific point in time, so generally when an event is triggering, and you expect something to happen and it's not happening. Breakpoints is generally the strongest tool that you have to determine why is this happening, and then you would be going through them methodically, seeing I expect it to be going in this pathing, why is that not happening, and then you check your variables and then you can see, well, this variable is not set to whatever value it should be, why is that, for example? Which brings us into the next point, which is finding references. So this particular, let's remove the watching of this value for now. This particular boolean here is something we created and only have use of here, but it is more than likely that when you have variables that you're going to be using them in lots of different places. So let's make a different event. We'll call it the F key. And in here, let's say that we set this value of execute code to true. This means that if we were to, actually let's go back and remove the breakpoint just so we don't have that, because we don't need that right now, like so. So we have now that if we press F, we're going to set the value of the boolean to true, and if we press E, we're going to check if the value of the boolean is true, and if it is, we're going to print. So if I press E now, it's not going to print anything because it's false. Then I press F, now it should be set to false, and now if I press E, it should be printing, and it does. So you might be wondering, this would be an example of why is it not set to true here? I'm expecting it to be set to true so I can print this value here. And then what you would be doing is you would be either finding references by clicking on the edge like so, which gives you this result here on the find results tab. You can also do it over here, for example, and do find references. And this is a very good way of finding where something is being used. So it will be, you can see that it's generating this this almost unique identifier to determine where is this specific variable being used. And if you want to go to a different place where it is being used, like we for example know that this is a get, but we're interested to see where is the value actually being set. Then we can see, oh, well, we have a set down here, and we'll double click on that. It will take us to that part of the code where it's actually happening, and you can see like, is there an issue here? Why is it not setting it to true, for example? Now, this works very well if you're in this specific blueprint with all of your code, but this might be a variable that you're actually accessing somewhere else as well, which means that you might have it in a completely different blueprint for some reason. This would not find it in a different blueprint because this find references only scans the blueprint that you're in. So if you wanted to find it outside of this blueprint, then you need to go to this this binocular. And this binocular allows you, if you click on it, to start searching in your other blueprints in your project and see if it can find it somewhere else, and then they would appear in this window instead, and you'll get a complete result. So this is very good for you if you're going to be finding your errors by going through reference finding to know about the blueprints, finding all blueprints. Sorry. The next part of debugging or finding errors in your code is the one that you have most likely run into already. So if we were to make a actor reference variable over here, we make it an actor object reference, like so. And then we say something like, on this E key, this actor should be setting its visibility. So we are gonna set it hidden in game, for example. Something like that. This is a very common problem that would happen a lot. So if we play and we press E and nothing seems to be happening, and then you escape to say stop the game, then you'll be presented with this pop-up, which is a part of the message log that is available to you with filtering on usually just errors. So the most problematic of things. And this is very useful. This is always something that you should strive to have not appearing at all, and if it does appear, you should fix it as soon as possible. And it's very useful because it tells you what the problem is. It's saying it accessed none, trying to read property actor reference. So it was trying to read this property, and it was not assigned. That's what accessed none means. So it didn't actually have a reference to an object, despite us saying that it is a reference to an object. And in addition to that, it will tell us which blueprint is it found in, which function is it found in, which graph and node. So if we were to click over here, it would bring us exactly to where the issue is in this case. And then we would see if we were to, for example, watch this value when we came to this part, breakpoint like so, and we run, and we press E, you can see that it has a value of none. So that is the issue why this is happening, which is why we keep using these valid checks for objects before using them, so we don't actually have these issues. Anyway, let's stop watching that value and let's stop. Oh, right. Also, while we're in this mode, I might as well describe some other things. Some other useful keys for you are the stop, which just will stop executing the program at the point where you are. And if we also have resume and skip. Now resume would be executing normally until whenever we run into ending up on another breakpoint by pressing a key, for example. And skip is referring to skipping a frame in the code. So if you, for example, have something like everything is looking fine, the particular frame that you're debugging right now, but you suspect that the next frame that is being drawn or rendered, there is when the issue appears. Then you want to frame skip, and then when the next time it happened, it would stop again. This, however, is an event-driven example that I have right here, so this won't actually execute in the next frame because it needs to get another E event from here, because now, actually it's not. It is actually. Let's go back. But we can't see it. It should be advancing a single frame. I am missing something here. I'm not entirely sure what, but that's what it's used for anyway. Unsure why it didn't continue like it should have. Anyway, now we see how we have all of these errors here. We can dismiss them for now. But let's hook back to that message log that we actually got, because we have this output log here. You can see in this output log, and if you don't see this immediately, you can find it on window, and then in developer tools, and then output log here. If you mark that one, you'll see this log. And this is very useful because whenever you build your game and when you run your game, the system will automatically print out a lot of relevant information, and things like these errors that we ran into is also being provided in here. So And it's also color coded, so warnings are yellow, errors are red, and they're easy to find that way. And in addition to that, there are also other things that are very useful when it comes to debugging. And that is drawing of debug objects. So if we right click and type in draw and debug, you can see that we have a lot of rendering debug options here. So in my opinion, you get away with a lot of these not being used at all. For me personally, the one I use the very most is the draw debug sphere. So I will be showing that. But just know that you have a lot of different options here. You have both for lines and planes and all kinds of things like that. So you can do more than just spheres, but this is usually what's being used. Like, for example, if you had a game where you were making a hand grenade and you want to see, well, I threw the hand grenade and the player didn't take damage. Why didn't it take damage? Well, okay, let's draw the bug sphere over there and say that it has the radius of whatever radius the grenade should have. And let's say that's 100, and let's say that we make the color red to indicate that it's very clear and stuff like that. And we can set the duration in seconds, so let's do 10 so we can actually see it for a while. And then let's make a thickness of, let's say, 10 also. And let's have the center in 0, 0, 0 and see if that ends up well for us. And then we'll compile and save. So now if we play and we press E, I'm not entirely sure where we have our 0, 0, 0 in this. We might have to make it a little bit bigger to see it. It should be somewhere in the middle. Let's do 400 radius. It should be difficult to miss now. There you see. So that's our debug sphere. So then you can see, well, okay, the player was outside of the debug sphere, or you can see that if you were calculating some kind of location, maybe place to put a spell or something of that nature, and you don't see the spell actually going off where you expect it to be going off, then you can draw the debug sphere just to show you where is the position that you actually calculated, and send that in as the center for the debug sphere and see if there's a mismatch between the actual location you calculated and what you had intended to calculate, for example. So that's where debug objects generally are useful to visualize specific locations and objects. Also for things like if you're doing collision tracing and you're trying to determine if a different character is being hit by a weapon, for example. You might be doing different tracings to determine are you hitting the character, and then you might want to do some drawing of debugs objects to align where you're doing these traces, so that you can see where do the traces go, was there an impact, and such. Anyway, I hope that makes sense. So just to reflect a little bit about what we've gone through then. We have print strings, which are useful for things that are not as time sensitive. We have breakpoints, which are really, really good for examining the situation in a specific point in time when a frame is drawn. We have the drawing of the debug objects to see things like where things are being put in the world, for example. We have the log, which can give us a holistic view over the errors and problems that we run into in the running of the program. And we also have finding of references, which allows us to find where we are using different variables and see if we have missed a specific place where they're supposed to be set or used in some way. In addition to this, there is one last thing that I should touch on a little bit, I feel. You see this debug filter up here. So in this specific case, we have a map here where we have 3 different characters all using the same blueprint. And that is where the debug filter comes in. So if we are, for example, in this case, we are the one that's a third person character without a number, then we have a 2 over there and a 3 over there. If we were to set this filter to number 2 and then run and press E, actually we need to do this as well. Press E like so, add a debug, and now we go and press E. So we can press E and nothing is happening. And why is that? Well, it's because, this filter here now is only checking what's happening for third person character number 2. And we are not actually third person character number 2. We are third person character without a number, which means that it's not actually going to stop on our breakpoints. We would have to change this to third person character like so, and then when we were to click here it would react. So this is something to keep in mind if you are having trouble with your breakpoints. You can also have a no object selected, which means that any of these third person characters running into this particular place would generate that the program would stop. In this case, the reason why it doesn't stop for the third person character 2 is because this one is not being controlled by me, so it isn't getting the inputs that I am using my keyboard with. Yeah, I hope that was not too overwhelming, and I hope it's allowing you to feel like you have some tools to troubleshoot your errors that you run into and use them to solve the issues that you have. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you might have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.